Welcome to a new test and teardown video. This time it's a Koden automatic direction finder ks-535. So here at the front they call it an automatic direction finder, but on the top it's a radio direction finder. So Koden makes marine equipment, for boats and such, and this one is finding the range or the direction relative from the boat by using two antennas. I'll show you here a picture of a more modern version of this product, and it also shows an example on an antenna. So it's two circles inside each other, or it's two horizontal located antennas in a 90-degree angle. And the way that it works is that signals gets stronger and weaker depending on the direction and the phase and all that kind of stuff. So this is what this unit can find, the direction relative to the way that you're sailing, right? So I think it works by you click some of these auto, I think it's probably this one, right? Auto direction finding, right? Our relative, and then this needle will show the direction, and then you dial this in, and then you will be able to remember the direction, because you will lose the direction every time they stop transmit. So the idea is you listen to their radio communication, and this one can handle the VHF frequencies. See, this is the radio amateur 2-meter band, and this is the distress signal by these finder beacons. So if a boat is lost, you will activate the finder beacons. So this is definitely what you want to try and track. If you heard a distress and you on the normal marine VHF channels, and you are trying to sail in that direction, and sooner or later they don't respond, then you listen to the distress channel, and then you can probably find that if you're close enough. And there you got volume, power, squelch, AM, FM, brightness of the display. There's probably also light in this one. We got tune, we can frequency adjust, probably dial in the channels or the frequencies or something like that. I don't know if this works. It's quite rusty all over the place, and this is typical with with electronics from boats. It's just the salt mist, salt water just goes in everywhere and completely corrodes stuff. So I think I will open it first and let's have a look. It's quite big. Look at that big hefty thing. And yes, definitely quite nasty, rusty here on the back. And here you see the two antennas. So this is the west-east and the north-south antennas. You connect to here. You can put in a speaker, and power supply is of course 11 to 40 volts, because most older boats there are 12 volt, but you also got 24, and so that should be able to do that. AC as well. So you can feed it with 100 volt AC. Interesting. Yeah, I think if I just unscrew this, maybe this will be the way that this is connected to the back panel or something like that, right? Maybe I should also remove those screws. And we are inside. I am so sad to say that I really feel we're not going to power this up at all. Just bad luck. But I will try and go into details about whatever I can find in here. So this is the top side, and it, as you can imagine, is completely full of salt salty corrosions all over the place, including, see, this kind of capacitor puke all over the place, completely corroded and shorted everything at all. So it's going to be a huge amount of work to try and clean this up, and this is just only one little area. It's more or less the same kind of state all over the place. We see some really nasty, see here, everywhere with voltage you'll see really bad corrosion. Oh yeah, definitely we're not going to power this up. So we got the, I can probably open the, oh, I need some tools to do that. What is that funny modification here? I don't know what that is. And there's also an interesting module here at the back. It's quite full of all sorts of filters and stuff. Obviously it's running on boat power with alternators and all that kind of ripple, so obviously you want some filters and all that. Oh, look at the nastiness here. Yeah, that's the indicator. I'll probably take it much more apart and look at how everything is built. Yeah, I'll try and open these cans here. So let's have a look in here. This looks like a PLL with the crystal and all that kind of stuff, right? And here, this part was a battery memory guard. Soft. So that's probably a 3-volt lithium. Somebody replaced that one for keeping up with the last settings. And this one I think is a synthesizer, or it says synthesizer, but that looks like the receiver signal and some sort of a mixer things. Yeah, what is that? A red LED. Oh, cool. Really oldie old style, huh? Look at that. 81. So I also find some other ICs. I can't remember exactly where it was. With, yeah, see, 81. Oh man, it's just completely corroded all over the place. But this is the top circuit board. It's really big and really full of ICs. Amazing. I want to show you the bottom circuit boards as well. Hang on. So this is the bottom side of the whole unit. It's really beautifully made. Look at that, nice heat sink. So I believe there's a switch mode power supply, as well as a AC entry, so the 100 volt AC. I mean, this looks a lot like that, right? What is all that stuff doing here, huh? And then that will be receiver stuff, and that could be the loudspeaker amplifier. Again, completely corroded. Ooh, it is green and blue and all colors of corrosion. But I mean, other than that, I mean, this board you could clean up probably. Ooh, there's also a blown up power supply, so yeah, it's not just the corrosion. Yeah, somebody's been using this one, and of course it blew up. But I really want to show you one more really cool thing. Look at the back panel here. Look at that. So there's a thin, flexible circuit board, and it's just being placed on top of all the different connectors, and then solder. Look at how cool that is. Ah, that is so funny. but this is a good way to do it reliable. You can't really screw this up. Right. So this cable, how is that connected, by the way? Aha. No, I don't figure that out. So this is also no, this is... No, I don't understand that. Oh yeah, now I understand. This cable here is actually the one that goes to this connector. This is the one that goes out the back. There is no connector out the back here. This is to interface to the flat cable. And it's the same here. Flat cable interface and then the rear side kind of stuff. How do you think about that? That is definitely some interesting discoveries. I really think we should also have a look here on the back. Definitely. So here's the radio receiver out in the light. Let's have a little better look. Yeah, I wonder what... That's probably some local power supplies, right? It's a little bit funny, this little breadboard area. You can imagine when they're doing hardware development, it could be interesting just to try out a little circuit here and then see how it works before you implement it in a new next version. Yeah, another one from 81. And that will be a little crystal filter. Or a ceramic filter for 10 megahertz IF. And then we got some, yeah, quite cool. This, what else can I say about this circuit board? Yeah, it's definitely just a 2-layer board. And those connectors are also a little bit funny, the way that this is made. Look at that. It's also a little bit weird size. So it looks a little bit like an MCX or something like that, but just oversized. So this is like 1.5 times an MCX. And then there is this little screw here on the top. So that is definitely a very special connector. So I'm taking it completely to pieces so I can show you all the cool things. And that is the back panel. It's just amazing, the design. And you can imagine, see, here's the antenna signal. So that is ground in the middle. So that just provides the necessary ground. And then it goes into this flat cable. Really? And here is mains entry, by the way. And look at that. It goes via this mains filter. And we, of course, go via the fuses and all that kind of stuff. But it also goes via this cable, flat cable there. But they take 2 in parallel, then they skip 1, 2 in parallel, skip 1, 2 in parallel. That's quite funny. So that is obviously good enough safety distance. Well, I can reveal to you that this is not enough for today. We need a little bit more distance, but that is how it is with the CE rules. So that is the fantastic back panel. So let me show you the big main board again. Ugh, it's just completely nasty. But I want to show you the rear side. It's a double-sided circuit board. And since this one is from, what, 1984 or something like that, right? It is definitely made by computer. but we still see a little bit of modifications, and also they're not following exactly the same kind of perfect rules. Sometimes they go 90 degrees, 45 degrees, and the distances between everything, the way that it looks like that. I mean, I would definitely call this a very sloppy layout job. I mean, look at the way that the stuff is spaced, and these super thin. Nothing here is optimized for maximizing copper or anything like that. But maybe signal integrity and good grounding and all that kind of stuff, that was not a problem back then. But it's kind of, I don't believe you. And see all the tracks, it's, you know, horizontal on one layer and vertical on another layer. That is the way that you route big 2-layer boards like that. And here is the front panel. I took it out because I definitely want to play with the meter and how the little motor is, or how the indicator works. But look at that, all those wires. And of course we got light in it as well, right? This is the signal level indicator, and there's also a little lamp in that one. And again, yeah, we could probably just unplug everything here and take those two boards apart, right? If I'm not... No, I am not so good. I can do that with one hand. So that will be port expansion and all the different chips needed to handle all the switches and all the LEDs and all those. Oops, it's falling apart here. So the 7 segments, oops, they go right here. And the interface to this 7-segment driver. That's probably multiplexed by all this. See, we got those resistors, integrated resistors as well. Nice. So this is operational soft switchboard, probably, right? Yeah. Quite nice. There's like a ton of circuit boards in this unit. But what I really want to play with is in here. It's gonna be fun to see if we can pull this out and play with. How is this? Yeah, see? It looks like it's moving. Aha! So, I think I figured out how this thing works. Look at that. What I'm doing here is I drive 2 of the coils. We got 4 coils, right? Obviously, this is just like a stepper motor. We got 4 sets of coils here. And then I can just connect to 2 of the coils and put in 2 sine waves that goes positive and negative. And then put the frequency a little bit higher on one of them. Instead of, well, one is 1 hertz and the other one is 1.3 hertz. And obviously this makes a little interference, and this will make the needle go around and around like that. So this just proves how this motor works, or shows how it works, I guess. So let me show you the back of this indicator. Here we got 4 bulbs, and they're 12 volts, but they're all completely open circuit. Obviously, the power supply blew up and over voltaged the whole thing. So all 4 bulbs are open circuit. And so that will be the gray one. Between gray and red will be the 12 volt. And then you got the 4 other coils here. And they share the same red common for the 4 coils. The funny thing about the coils, let me try and lift this up. Look at that. So this is just like a stator in a brushless motor. This is actually what it is. And in here is a little round magnet that is probably a little pointy bearing or something like that here. And then it goes to the needle that moves like that here. So yeah, quite a beautiful indicator. I really love this type of design here. I think that was more or less what I wanted to show you guys from this fantastic instrument. It's just too bad it was completely rusty, corroded, beyond repair by a huge factor. So there was absolutely nothing to do but just throw it out back in the junker where it came from. And yeah, at least we got a little fun out of looking at all the different circuit boards. See you again soon. Bye bye.